opportunity to speak about some of the work that we're doing at NC State University in conjunction with the Wildfire Conservancy, as well as the funding through CAL FIRE. It's really interesting what we've heard so far today, and I think we at the Textile Protection and Comfort Center in NC State, we approach it from the opposite side. So we're looking at it from the gear perspective to begin with, and trying to go back to exactly what you were mentioning, to coming from the kind of epidemiology side of it. How do we meet in the middle? And so the work that we've been doing, there we go. So a lot of times we focus so much on structural firefighting. And we think about the exposures that structural firefighters have, and then we think about, well, there are also those exposures, the smoke that's there. You know, I've been to meetings before where we presented, and you know, the person right before me would say, "Oh, well, it's just organic smoke. It's just forestry." Like it's not how that works. That smoke is a problem, and regardless if we're looking at wildland or structural, we have to figure out what fits that job. We can't do this one size fits all. And as you'll see, we've been able to look at and evaluate a number of different products as we go through. Again, we started looking at this from the standpoint of how do we make these tests? How do we test these things in a controlled environment, in a controlled scenario? And so we happen to have environmental facilities or environmental chamber facilities at our institution, at our facility. And we have animatronic head forms. These head forms we actually started developing, started working on with the company that makes them back during COVID, because we were looking at cloth face coverings, answering those questions of, do they work? How effective are they? All these different types of non-traditional respiratory protection, as we kind of refer to them. And hopefully I can get these videos to play. But we have this animatronic head form that we can control the movements, and it may be a little jumpy if it starts moving here. We can control the movements. The head shakes, does a nod up and down, side to side, ear to shoulder, and the mouth moves up and down as well. And so when we look at this, how do we use this is where really where we started during our project focused on face coverings, which is funded through the CDC at NIOSH. So we spent an entire 2 or so years developing a protocol. How do we make sure the method actually works? Because then we say, okay, well, during COVID, we were looking at that specific aspect, but we always knew that there was going to be other applications for this. So how do we move into this area of wildland respiratory protection, which, if you are familiar or not, the NFPA does have a standard for wildland respiratory protection, which, to my knowledge, nothing has ever been submitted to. So there's nothing certified out there. Nothing's been submitted for certification. And you go back and forth looking into that. Part of the reason is because there's no perceived market. Well, there's no market because there's no product. And so we're just sort of in this endless cycle where no one takes a step out and says, hey, can we make something different? That question that was brought up earlier of, we don't want perfect to be the enemy of just progress. And can we give these people something? Because just as we talked about with COVID, during that time, you're not coming down from 95% for these people, especially with the wildland firefighters, because the public, the civilians in these locations as well, are impacted by this, and they really are wearing nothing. So you're really hopefully coming up from nothing, not that the other way to think about it, coming down from 95. And so we started looking at this, but wildland firefighting is really difficult. If it wasn't difficult, we'd already have a product. But just as was mentioned earlier, the issue with the facial hair, the issue with the amount of work, the type of work that's done, the duration of how long you're going to be out there. And so it's really imperative to get that input from the individuals. What is acceptable? And it's not just a monolith either. You have different jobs within the wildfire response, whether it's a hotshot crew or a mop up or something like that. They're going to need different things. Let's see if I can get this to go again. I don't know, Mary, if you can click. All right. Oh, there you go. Now he's moving. It's a little jumpy. We do have 2 of these head forms now. So this is our first one we've had for a number of years. The other one is a full torso. And so the head moves on that as well. We can control the breathing rates. We can control the times of breathing, the movements, and all of that. We can also, on the new head form, we can record someone's breathing pattern, and we're supposed to be able to upload that to the mannequin so it replicates it. So whether that's the breaths per minute, the volume of air, all of those different things. So what can we look at? What is out there for wildland firefighters already? or at least what's targeted towards them. And so what we have are a number of respiratory protection devices that we started evaluating through our project. This is everything from a full face PAPR, powered air purifying respirator, the half faces, quarter face. We went to filtering face piece respirators. You can see bandanas, which are sort of the state of the art, as we'd say, for wildland firefighters, at least what's accessible. Neck gaiters, hoods, these barrier face coverings that sort of came on the market during COVID. And so we started looking at all of these. We have data from all those, and then we found more, and we started looking at more. So these in the gray are ones that we haven't added or updated the data for that you'll see in a moment. We have over 20 different products that we've put through the paces on this head form. And it's not just a single, evaluation. We have multiple, probably, I believe it's 5 to 10 replicates that we do for a long period of time, going through the protocol of the movements. So we can actually, in our previous work, we looked at the impact of movement. We looked at the impact of fit, of breathing resistance, or breathing rate. So what type of data do we get? Just to orient you really quickly, one of the things that we decided to do early on, we were really focused on getting information, educating the general public and firefighters. And so when we talk about the filtration level, we wanted to stick to something that they're familiar with. So in N95, everyone sort of figured out that 95 was 95% filtration efficiency. So when we went to the full mask evaluation, we stuck with that. We wanted the material level evaluation to match up. So I refer to that as total filtration efficiency, which takes into account both the fit as well as what comes through. Normally referred to that as inward leakage. But when you talk to the public, it's a little difficult to go from 95 to 5 and get them to understand it's the same thing. So as you can see, we have two different breathing rates here, 15 liters a minute and 28 liters a minute. And this is cyclical breathing. This is not just as the N95 test or the Code of Federal Regulations test is. It's not just a constant flow. It actually is a breathing pattern. We have the breaths per minute. And so the 28 is pretty close to that 85 liter a minute that we look at with the standard test. But you can see we have our, I believe, the respirators. There we go. The respirators on this side, as you would expect, have much higher levels of performance when we're looking at total filtration efficiency. And this is at 0.3 micron. We also collect other particle sizes so we can differentiate those out. And then we go on this side, we have our alternatives. As you would expect, the bandanas, the neck gaiters, the hoods, things like that are in the lower end. Now, some of the not weird, but odd things that we noticed was normally you would expect to have less filtration efficiency when you're pushing more air through, but some of these actually increase at the higher airflow. Part of that comes into the fact that these materials are flexible. If you've ever worn a mask that's not breathable and you breathe in really quickly, it sucks to your mouth. Well, then you just change the surface area size because it's limited to that location only. And we've run into this with the head form. You can actually see it suck into the mouth. We've had to do things to keep it from doing that, to affecting the measurement. But another way to look at it is not just the filtration efficiency, we also have breathing resistance. And so when you start looking at the breathing resistance that's measured while we're doing the testing, if we were to take a square and say, okay, hopefully somewhere in this box is where we want to be. We want to have some things that are maybe above 50% filtration efficiency, but below that inhalation breathing resistance, right around about 250, I believe. And you can see there's a lot of products that fall in there, depending on which breathing rate that we're using. When we expand that out to the high breathing rate, we actually get a couple of additional products. So we have our different PAPRs, our filtering face piece respirators, a couple of the barrier face coverings. This is a quarter face APR, and then even one of the neck gaiters up here gets into that region. So this idea that, this is good or this is bad is really dependent on where you're doing the testing. What are you requiring of it? What are you expecting of that device to do? Because it could be that we have very different needs depending on the actual firefighter that's using it. Now, one of the other things that we are trying to do is we move not just from the laboratory, we want to move into the field as well. So this is a preliminary study. We were actually doing a completely different project looking at fire investigator exposures in a smoke-filled environment. And we said, well, we have to burn the buildings, the structures anyway. So we took a table and put our head forms on there and started to see, can we collect particulates? We've done a lot of work looking at particulate protection for structural firefighters. It was really easy to get people to pay attention to it because you can see the soot. You can see the smoke. You can see that on the face, on the neck when they take their gear off. And it was really easy for people to say, okay, that's probably an issue. We wanted to do kind of the same thing here, right? what gets inside. And so inside these head forms, the same animatronic head forms, we just have different skins for them. But we took the skins out and we put particle impactors on the inside. We also had some sorbent tubes that we were measuring, but we had one pump hooked up inside the face and one on the outside. Look at this comparison. As you can hopefully see, when we had nothing on the head form, you start to see this line of these particulates. It's really kind of difficult to keep the table in the actual smoke plume. So we tried to move it around, so it wasn't ideal, but just to give us an idea. When you go to the bandana, it basically looks the same. Giving that idea that these are not providing much protection. They're exactly what we showed previously. Yeah, I can hear it too.
If you could mute yourself if you're online, that'd be appreciated. Thanks.
Thanks. And so we have, like I said, the no mask versus the bandana, and then you get down to the N95, and this was a standard cup style N95, which does not really fit the face form. It's supposed to be a medium-sized face based off the ISO measurements. It doesn't fit perfectly well. NIOSH has the same thing, and they've been actually changing the face form to actually make it fit a little bit better. But we do get a lot better reduction in just that line that you can see where those particulates are, and these are going from the larger, smaller in size there. And so we're going to continue doing more of this. We actually want to do more measurements to look at those vapors, to look at the PAHs that were mentioned earlier. We did take the filters out of here. We did extract those, put them into gas chromatograph. We were able to detect a couple of PAHs on each one of those, and we'd like to be able to quantify that a little bit more. But moving on to the last piece here is the piece that we're just did in the past month as our physiological wear trial. And because it's not necessarily just about the protection, it's what are they willing to do? What is the impact on the person? And trying to replicate this, it's been a challenging endeavor. We don't have quite as many wildland firefighters in North Carolina as some places, but we tried to get people that had wildland experience, ones that would go out to the West Coast and other different places, or just in our local areas. And so we had an hour-long protocol. We wanted to make sure they were wearing it more than just, say, a 15-minute try-on period. And we were looking to bring in 12 firefighters a session. Again, that turned out to be a little difficult. We ended up with somewhere between 3 and 8, depending on which day we were testing. So we're not quite done with it. We're hoping to pick that back up. But these are the 12 products that we narrowed down to. The first 3 that we looked at in a cohort were the full face respirators, whether those are PAPRs or just APRs. Then we moved to the half faces. And so we have a PAPR or 2 PAPRs, one with a blower unit, one where the blower unit was on the back of the neck as opposed to the waist. The next day, looked at quarter face APR, the half face shield, or with a shield or a shroud, and then the N95 with a flame resistant shield as well. The last day was looking at more of those kind of non-traditional products, your bandanas, your neck gaiter. This one in particular, most of the subjects were like, we really wanted to like that until we put it on. So getting that feedback from them is so critically important to understand what is it about it that they don't like. And so what we did is we had them go through a protocol where they did kind of a acclimation period first. We did 4 rounds a day. The first, they just went out with an N95 to serve as a control. And then they came back. We did pre-test questionnaires. They went out for a 1-mile walk, not just a walk, they were hiking kind of up and down different terrain. I'll show you what that looks like. Then they did hose or line digs, and then they did a walk back and then a hose lay, and then we repeated the thing. It was a very long day, so we started about 8:30 in the morning. Subjects didn't leave until about 6 p.m. And they were very stressed throughout the whole period. We checked with them regularly, but we were also monitoring physiological responses. We were getting the feedback from them, looking at a number of different things. And so this is giving you an idea of the different terrain they were going over. We had anywhere, like I said, from 4 to 8 different people at a time, and monitored them continuously. And the physiological data, which is really important that we're trying to get, we want to look at core temperature. So they took core temperature pills as they were in the morning. We made sure those were getting into the digestive system so that we were getting the true core temperature, not impacted by drinking water and hydration and things like that. We also were using non-invasive external core sensor, which works off of partnering with a heart rate monitor and tries to calculate things on an algorithm, with the idea of hopefully there may be something there that we can use that firefighters actually might be able to take advantage of in the field, because you're not going to be able to take core temperature pills every single day, and you wouldn't want to do that either. But we're trying to see, is there an alternative? We also have not just the core temp, the heart rate, we have some skin temperatures, we have respiration rate that we're going through all this data now that we collected over the entire time. Then they came back and they did our questionnaires, whether it was a pre-questionnaire at the beginning or the post-questionnaire, really comparing everything. We wanted to use the N95 as sort of a control to say, okay, you wore this every day. Was this better or worse than that? And so we're going through all that data now, but we also did a focus group at the end of every day and just kind of had them talk about the products that were worn, because everybody, most days, everybody wore every product. So we have those recorded. We're transcribing those now. Just to tell you, like I said before, there was definitely some that everybody was in agreement, like this, we wanted it to be great, but it was terrible. We couldn't breathe here, or we had to take our helmet off to do this. There's a lot of those trends that popped up that we can absolutely take those and move to the next stage, which is to incorporate all that feedback into an actual product, not forced on them, but designed with them in mind. And that was one of the things that came out. They said all of these products are meant for something else. They're not necessarily designed for our application. So some of the key takeaways from the initial testing, we do see highly variable levels of protection as well as breathing resistance against mainly the particles. We are hopefully going to move and use our environmental chamber that we have to do vapors as well, but that piece hasn't happened yet, because that's also a very important thing on the fire ground to look at. But we get this wide range of performance, but then the physiological burden, we have to balance that. And so that's the data now, hopefully for the first time, we've collected a significant amount of information on that we can go back and look at these 12 different products across all these different subjects and say, what's possible? It's not necessarily to say that we're going to mandate this or that or whatever it is, but to say what's possible so that we can move forward and design something specifically for those wildland firefighters. And with that, I will finish up. I'm happy to answer any questions. I'll be here the rest of the day and in the week for the ASTM meetings. If you want, this is our group's website, so we got a little bit more information on there, as well as other projects that we're working on. So